So here's a integral that I messed up for a while today, so I thought I'd admit my folly. Here we go. So was this the indefinite integral of 1 over x ln of x cubed and dx? And I thought about this a thousand different ways, and then I kind of screwed up my rules of differentiation when I tried this earlier, and I'll kind of show you what I did. But here's what I should have done. What I should have done was looked at this piece right here, which is the piece that was bothering me the most. And I should have let that equal u, and I should have said u equals ln of x cubed. And then taking the derivative du dx. And this is, I actually did get here, then I kind of messed this up. I knew what the rule was here, but I applied it poorly. And what is the rule here? What is the first derivative of ln of u, or ln of f of x? So what is it here? Yeah, exactly. It's 1 over u times u prime over 1. A lot of people just write it like this. And this makes perfect sense is an ln. We talk about this backwards all the time, but I kind of messed it up today when I was taking this derivative because I kept putting the ln into this mess, but they're asking you for this piece. So it is, so it's 1 over x cubed times the derivative of x cubed is 3x squared, isn't it? Over 1. So I'm just going to write this out a bunch. Du dx is equal to 3x squared over x cubed. That's cubed. It's cubed. Right? So I'm going to simplify that out a little bit more and then get on with my point. So here's my, finally, x squared over x cubed is 1 over x. So this is actually simplifies out to 3 over x, and I won't admit to you all the stuff I thought it was. But anyway, there it is. So then from here, remember, I'd like to get a replacement value for dx if possible. So I'd like to replace this dx up here, Dylan, with this dx down here, but I have to do a little work first. So if you do this, you can just multiply both sides by dx, and you get du is equal to 3 over x dx, isn't it? Then if I divide both sides by 3 over x, otherwise known as multiply by the reciprocal here. Zach, yeah? Okay. So if you don't mind, I'm asking you to buy the fact that this is x du over 3, right? Because I multiplied both sides by the reciprocal of this. It's equal to, and here's the dx. Killian's laughing. I have a booger or something hanging out of my nose. What? Calculus is fun. Everybody hear that? I have a little tear running down my face. Golly, thanks. Right? So now let's do, if you don't mind, let's substitute a bunch of stuff. Let's substitute u for ln of x cubed and x du over 3 for dx, right? So I think this substitution works really good now. To go back to the original, we would have 1 over x. It was supposed to be ln of x cubed, but of course that is this, isn't it? So we'll substitute in u times x du over 3. And I'm asking you to notice just a couple things here. This x right here and this x right here cancel, don't they? And I'm also asking you to see if you will buy the idea that this is 1/3 right here. Is everybody okay with that? Is that okay? So if you don't mind, I'm going to take this 1/3. I'm going to cancel these. I'm going to take this 1/3 out right here. So I take 1/3 times the indefinite derivative of du over u. And du over u is what? Is ln. So if we integrate here, thank you, yeah, we integrate, we get equals 1/3. Of course, that's just 1/3. We know that du over u is ln of u. So here's ln of u plus c. Here's that u right here, isn't it? Remember, we're going to resubstitute ln of x cubed equals u. So I'm just going to put that in there, if you don't mind. And we'll get 1/3 ln of x cubed plus c. Is that all right? We resubstituted this back in because at the end we had, right, it's just this ln of u, but this is kind of what we've done the whole way along. At the very end, you put this back in. What makes it weird is that if we go back and look, the value of u was that. So we got down here and we had du over u, and we said, okay, that's ln. It was ln of u. And we went back to resubstitute, and we realized, holy crap, u is equal to that. So that's how we got that twice. We can take a look at it in the calculator really quick. And here it is. Here. Maybe here. No, that's the wrong one. Here it is right here. Take it easy. Don't leave me. Don't leave me hanging there. Here, it's right here. So this is our CAS Inspire, the new CX. If you have a CAS Inspire, please go to education.ti.com and upgrade your software from 2.0 to 3.1, and you get all of this stuff. So I put this in. Indefinite integral of this equals that. And there it is. As weird as it looks, right? And what they did is they tucked their 1/3 underneath there, didn't they? All right?